In this video, we're going to look at questions 8, 9, and 10 from your test review. First question here asks us to convert either from degrees to radians or from radians to degrees. Now remember, when we're converting, our conversion factor is pi and 180, and we just need to figure out which way we want to write that fraction to get the proper conversion. On part A, we've got 250 degrees. It is an angle in degrees, and I want to convert to radians. So that means when I multiply with my conversion factor, I want to put degrees on the bottom so that my degree units can cancel out, pi radians on the top so that I end up with radians. And so I get 250 pi over 180, which would reduce to 25 pi over 18. Next up, part B, 420. Same thing, we're in degrees, so we're going to multiply times pi over 180, and I end up with 420 pi over 180, and this reduces to 7 pi over 3. All right, now question C, I'm starting out with radians and I want to end up with degrees. So this time I want my pi radians to be in the denominator, so my radians will cancel out, and the 180 degrees on the top, so that I end up with degrees. I have a pi on the top and the bottom, and those are going to cancel out. And then 7 times 180 divided by 12 leaves me with an angle of 105 degrees. Finally, 7 pi over 3. Again, we're going to multiply times 180 degrees over pi. I have pi in the top and the bottom, so they're going to cancel out. And 7 times 180 over 3 is equal to 420 degrees, which looks familiar. That was the same problem we had in part B, just converting in the other direction. All right, next question. We have angle theta in standard position. 0 is the origin. P is the point on the terminal side of theta with coordinates 8 and negative 15. We want to find the length of OP and the measure of theta. So the first thing I want to do here is draw a picture of this triangle. I have coordinates 8, negative 15, and so that means that my point is going to be in the fourth quadrant, and therefore my triangle is in the fourth quadrant. So here's our triangle. Here's O, here's P, 8, negative 15. And so that means our X side, our horizontal side here is 8, and the Y side is going to be negative 15. Now if we do the Pythagorean Theorem, we can find out that our hypotenuse, our radius here, is 17. And so that would be the length of OP. OP is equal to 17. Now the other thing we're asked to do is find the angle. Our theta is going to be this full angle here, but the one that we can find on our calculator is our little reference angle right here. So to find that reference angle, we can pick any trig function that we want. We've got all three sides of the triangle. I'm going to choose tangent. And I know that tangent of the angle is going to be y over x. And so to find the angle, I'm going to use the inverse tangent on the calculator. Inverse tangent of negative 15 over 8. And if you put that in, your calculator is going to give you back negative 61.927. And so that angle is our reference angle. That reference angle is negative 61.927. But what I really want is the angle in standard position going all the way around to there. And so to find that angle, I'm going to do 360 minus my reference, 61.927. And so the theta that we're looking for is 298.072 degrees. All right, last question. Given that cosine theta is 5/12 and tangent theta is less than 0, determine values for all 6 trig ratios. Now in a question like this, we've got to figure out in which quadrant to draw our triangle, and we're going to do that based on these 2 pieces of information that they gave us. First of all, cosine theta is 5/12, and what's important about that is that they're saying that cosine theta is positive. And so I want to figure out what quadrants is cosine positive in. Well, that happens in, of course, quadrant 1, because they're all positive in quadrant 1. And then also quadrant 4. Remember that cosine goes with the x-coordinate, and so it would be positive in quadrant 4. Then my other piece of information is that tangent theta is less than 0, which means tangent theta is negative. So I want to figure out which quadrants tangent is negative in. And if we remember that tangent is slope, it's going to be negative in quadrants 2 and 4. And so the one quadrant where both of these things are true is quadrant 4. So I'm going to draw my reference triangle in quadrant 4. There we go. And the information that I had is that cosine theta is 5/12. And that means that 5 is my x and 12 is my r, because cosine is x over r. So this side is 5 and this side is 12. To find the other side, I'm going to do 12 squared minus 5 squared, and that equals 119. And so this side would be the square root of 119. And since we're in quadrant 4 and it's the y side, it's going to be negative. So now we have everything that we need to write our 6 trig functions. I'll start off with cosine theta, which is the one we knew, 5/12. Secant theta is going to be the reciprocal of cosine, r over x, which would be 12/5. Sine theta is y over r, and so in this case, negative square root of 119/12. Cosecant theta is going to be the reciprocal, r over y. So I get 12 over negative square root of 119. Now I can't leave that 119 in the denominator, so we're going to rationalize square root of 119, square root of 119, and I get 12 times the square root of 119 over 119, and this value is still negative. All right, so now we're up to tangent. Tangent theta is y over x, which in this case, negative square root of 119 over 5. And cotangent theta is going to be the reciprocal of that, x over y, 5 over negative square root of 119. And one more time, we got to get rid of that radical in the denominator. So I get 5 times the square root of 119 over 119. And this one is also negative.